Hi, welcome to Learning Monkey. I am Raghuir. In this class we will discuss about predictive parsing. In our previous class we clearly discussed about recursive descent parsing. This is an extension to that. Please watch that class and come back here. Otherwise you don't understand this class. The link for the playlist is provided in the description below. It's a bit difficult to understand predictive parsing, but if you have good intuition about recursive descent parsing, it's very easy. Please concentrate much. So we are going to take an example and understand step by step what predictive parsing is. So predictive parsing, this is a recursive approach. So in this predictive parsing also we are following the recursive approach, means we are what we have done in our recursive approach. We are taking a context-free grammar, and for each non-terminal we are writing a function. Similarly, we will write a function for each non-terminal here in predictive parsing also. But this is going to eliminate backtracking. In the predictive parsing, we are going to eliminate backtracking. How we eliminate that we are going to understand with the example. So in order to eliminate backtracking, we are using lookahead one input symbol. So what's lookahead one input symbol? That we will try to understand along with the example. Let's take an example grammar. This is our context-free grammar. This is the example which we are choosing. Statement is a non-terminal. Non-terminal tends to expression. Usually expr is a non-terminal in our previous grammars. For simplicity's sake, we are taking it as terminal, means expression is identified. This is a terminal symbol. If is a terminal symbol, terminal symbol, open brackets is a terminal symbol, expr is a terminal symbol, closed bracket is a terminal symbol. Statement, again calling statement. Like that for opt expr means optional expression is a non-terminal. So we are going to non-terminal optional expression. It is going to take epsilon or expression. So this is the grammar which we are following. This grammar is going to identify expressions, if statements, loop statements and other statements. Using this we are going to understand what predictive parsing means. And we already discussed about what's lookahead one input symbol means. Let's try to understand what lookahead symbol means. We are taking a variable called lookahead. This lookahead is going to point to the first input. This is our input string. What it says, we need to check for the expression loop expression, loop statement. What's the first input symbol in the loop statement? For. Don't think that for how it is taking it for as input. For our parsing technique, the inputs are keywords, tokens that come from lexical analysis phase. So this is a token, open bracket is a token, semicolon is a token, expr is a token, semicolon is a token. Think about it in tokens. So based on the assumption that you already know what's lexical analysis phase, what's the inputs to the parsing phase, then only you will understand. So lookahead is looking one input symbol in our input. You can take lookahead 2 symbols, you can take lookahead 5 symbols, but writing the code is bit complex. That's why in our textbooks we will follow lookahead one symbol. We are looking ahead one symbol in the input. Based on the symbol we are going to write the logic. That's why it is eliminating backtracking. How it is going to eliminate? Let's if you understand the code, you will understand how it is eliminating the backtracking. Void statement of. For the statement we are writing a function. What we have written in our previous class, recursive descent parsing class, take the first production in the statement. So these are 4 productions. Statement tends to expression is one production, statement tends to if is another production, for is another production, other is another production. Take the first production. If it is matching, take it. Otherwise backtrack, take the second production. If it is matching, take it. Otherwise backtrack, take the third production. That is what the code we have written in recursive descent parsing. But this is not the case in predictive parsing. We are changing the code based on the lookahead symbol. So see here, statement switch look ahead. Look ahead is a variable. It is going to hold the first token in our input symbol. Not only first, in the beginning it is going to take the first input symbol. Case, if the look ahead is saying that it's an expression. So what's our statement says? Expression, check for expression and semicolon. That's why match expression, match semicolon. So what is match function? Let's try to understand what match function means. Match of terminal. So here from this let's try to understand the next cases, then we are going to understand match function. Match function we have given it as in short we are giving it as m. So case if our look ahead symbol says if, call this. What's the if statement? If, match for if, after that match for open brackets, after that match for expression, after that match for closed bracket, then call the statement function again. Same way case for loop, match for keyword, match for open bracket, optional expression, call the optional expression. Match for semicolon, optional expression, again call the function optional expression. Match for semicolon, optional expression, again call for of closed bracket. These are the things executed if you found this case for loop. It is going to check for the syntax of our statement, loop statement. That is how we are predicting based on the input. See here, if you elaborate this, whenever you call the statement, based on the look ahead symbol, which case it is going to check? It is going to this case. It is leaving the remaining cases. So we are eliminating backtracking. Previously what we have done in the coding, take the first production, means first production is expression. Here we are not doing that. By taking a look ahead one symbol in the input, we are eliminating backtracking. This is the point you have to understand. So what's the match function means? See here, we are calling the function match function. This logic we already discussed in our recursive descent parsing. We are making it as a separate function. Why we are making it as a separate function? Match of terminal t means we are sending in place of t we are placing for. If look ahead is equal to, what's the look ahead says? For, equal to t, what's t says? For. Both are same. Input symbol, our matching is same. We are going to check for the look ahead is going to move to the next input symbol. This is done in our recursive descent parsing also. In order to write this statement for all the functions, in place of m we have to write this statement. That's why we are making it as a separate function for match. If the input is matched with the for loop for a keyword, this look ahead is moving to the next input symbol. What's the next input symbol? Open bracket. Now we again call the match of open bracket. Yes, if it is matching to the open bracket, look ahead to the next input symbol. What's the next input symbol? Semicolon. But what it is saying? Optional expression. We are calling optional expression. If look ahead is equal to expression, but here look ahead is pointing to semicolon. So this if is not executing, but this function has been completed. If optional expression function has been completed, what's the meaning of that? Indirectly we are taking epsilon. We are moving to the next. What one? Next we are calling the next function. What's this says? of semicolon. Yes. In place of optional expression, we are indirectly taking epsilon. This is the point. This is the second point you have to understand. So we have written only if statement for expression. Is there any condition for epsilon? Epsilon means no input. Don't take input here. How we are leaving this optional expression? By checking the input symbol. If it is semicolon, this if condition is not working. If you come out of this if condition, there is nothing to execute in this optional expression function. Nothing means this function is completed. If this function is completed means, but we are not moving ahead. We are still staying on the look ahead symbol semicolon. Means without input, we eliminated this. That is what epsilon means. This is how epsilon is executed in programming. In context-free grammar, if you place it as epsilon to the coding level, this is how we are going to write the code to execute epsilon. So we are making it slow because you have to understand this. This is very, very important to understand. Okay, this is how we will write the code for predictive parsing. Predictive parsing, by taking a look ahead symbol of one look ahead symbol, we are going to elaborate this expressions. Let's take one more example from our real-time expression evaluation and how predictive parsing is choosing the expressions and choosing the productions. E tends to T E dash. This is the productions. These are the context-free grammar which we are using for identifying the expressions. ID plus ID star ID. So the first look ahead symbol is at ID. How this is going to elaborate? E tends to T E dash. Yes, in E we are having only one production. We are calling T function, E dash function. Now T function is going to elaborate. T we are having F T dash. We are elaborating F function, T dash function. Now F is going to elaborate. But what's our look ahead symbol says? ID. But F is having two options. You can go with open brackets this production, or you can go with ID. But here we are going with ID. Why we are going with ID? Because our look ahead symbol says that it is ID. That's why we are going with production ID. But this is not the case in recursive descent parsing. What recursive descent parsing says? Take any one production. If it is matching, okay, go with. Otherwise, take the next production. If it is matching, go with it. Otherwise, take the next production. That is what recursive descent parsing is doing. But here in predictive parsing, we are going along with the input symbols. Here it is matching ID. That's why by checking the input symbol ID, we are going with production ID. And one more step. After that, T dash has to be elaborated. So why T dash is taking epsilon here? T dash is having two options, either go with star T dash or epsilon. Means the first input symbol is star. After ID, what's the input symbol we are going to check? Plus. It is not matching with this production. If it is not matching means we are leaving it. Coming out of if statement means epsilon. That is what this coming out of if statement means we are leaving that T dash. We are completing the T dash function. Completing the T dash function means leaving it without, we are not considering any input symbol from here. Means without input we are moving to E dash. That is what epsilon means. This is how predictive parsing works. Still it is a recursive function. That's why in our last class we discussed about problems with recursive function calling another function, function calling another function, function calling another function. Take it as a big picture. If you want to write functions for all the grammar that representing the entire language, how many statements will be there, how many expressions will be there, how many operations will be there. This is bit complex to write and it is difficult to execute in the compiler. It will occupy a lot of random access memory. So in order to overcome that, recursive methods are not good for writing the context-free grammar, elaborating the context-free grammar. In our next classes, we are going to discuss about table-driven methods. Before table-driven methods, we have to understand few concepts, first and follow concept. We will go with first and follow concept. Then we are going to understand table-driven methods. Hope you understand the concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.